Okay, here we go. Math 2, Unit 5. Let's get started. So, we're starting here, obviously, October 5th with 5-1. Finishing up the unit on block day. And we will review the beginning of block period and then go ahead and take the test the second half of block period down here on, for you guys, it will be October 17th or 18th. Okay? Any questions on this? Now, please remember, homework, quizzes from the previous unit can be made up for full credit until the end of the next unit. So Unit 4 material, homework and quizzes, you can make them up until the end of Unit 5. Now, makeup tests, you're allowed 2 per semester. So it's not always great to jump in on the first bad test you have, just in case there's another one that's worse a little bit later on. But after Unit 5, we'll easily have, halfway through the semester. So that might be a good time to, if there's one of those tests were bad, you might want to think about redoing one of those before we get too far down the road. Okay, any questions? All right, so turn the page to the back of your objective sheet. All right, the first thing we want to talk about is what a polygon is. A polygon is a closed figure formed by 3 or more line segments or sides. So you can look around on the wall over there. We've got a bunch of different polygons. You can see that one poster over there. We have triangle, quadrilateral, pentagon, 5-sided, hexagon 6, heptagon 7, octagon 8, nonagon 9, and decagon 10. Okay? And I'm not sure what 11 is, but I know 12 is my favorite. It's dodecagon. And beyond that, we really just say like 13agon, 14agon, 15agon, 16agon after that. At least I don't know if there's any names made up for them, but I'm not aware of them. Okay? So there's basically 2 types of parallelograms, or excuse me, not parallelograms, polygons we talk about. We talk about concaved and convexed. Now, concaved, you can see that almost like a cave, you can go into it, right? You can go into the cave. That's why, I don't know if that's why we call it concave, but you get the idea. It's a good way to remember that. Convex will have all exterior vertices, okay? And obviously, these are the sides. I don't think I have to mention that. But then these corners, all the corners are called vertex. Or if we talk about more than one, we talk about vertices, okay? Vertex or vertice. All right, so here's what we're going to do. We're going to fill out this chart and this table. You guys are going to do this on your own. I'm going to give you about 10, 15 minutes to do it. I'm going to start with, I guess, the 5-sided polygon known as anybody? Pentagon. Now, it doesn't have to be perfect. It just needs 5 sides. So I want you to use a straight edge and just make any old pentagon you want. It doesn't have to be pretty. But I would like you to make some efforts to at least make all the sides nice and straight. So I would like you to use a straight edge. I'm even messed up my straight edge a little bit there. Okay. Now I will give you a straight edge in a minute. I have plenty. Okay. So right now all you need to do is watch. All right. So the first job you have is to draw a 3-sided, 4-sided, 5-sided, then 6, 7, 8-sided. Actually, no 7, just 8-sided polygon. Then the next thing it says is, with each polygon, draw all the diagonals from one vertice only. So a diagonal is a line from one vertice to any non-adjacent vertice. So if I pick any corner, it really doesn't matter which one. I'll just choose this one right here. I wouldn't draw it to that vertice because that's just a side. So it's to any other corner or vertex that is not adjacent to it. So there's one. And then the only other one to draw is right there. Okay, so what have I created there by drawing those diagonals? I've created 3 triangles. That's right. 1, 2, 3 triangles. Okay? And what do we know about the interior angles of any triangle? The sum of the interior angles of any triangle is 180. So there's 180 degrees of interior angles here. There's 180 degrees of interior angles here. And there's 180 degrees of interior angles in that third triangle. And since each of those angles of each triangle is part of one of the angles of the pentagon, we could simply add these 3 up and get the interior angles of the pentagon, couldn't we? Right? So if you add up the 3 180s, what you'll have is the interior angles of the pentagon. For instance, these 3 angles make up this angle of the pentagon. This angle of the triangle is one of the angles of the pentagon. These 2 angles of these 2 triangles make up this angle. Obviously, these 2 angles make up this one. This one stands alone. So clearly, if this triangle, and this triangle each have interior angles of 180, the pentagon must have interior angles of 3 times 180, or 540. Great job. So let's go down and fill out our diagram down here. So number 5 is right here. It's pentagon. 5 sides. How many triangles in our picture of our pentagon? 1, 2, 3. And we said the interior angles of the pentagon was 540. All right. So I'd like you to fill out the 4, the 6, and the 8. I'll give you a couple minutes to do that. And then, if you can, try and figure out the n. We use nth for any, basically. So any number of sided polygon. Could you figure out some kind of formula? If you can, do the nth and try and answer these 2 questions down here. That's what we're working for. Any questions? Okay, I'll give you about 10 minutes.